Okay guys, I'm just gonna go straight into the solution of this 2009 paper. The first questions. Apparently, well, obviously look, there's a product of two function, and obviously the u part, it looks like something like uv. The u part is 1 minus x power 3, and so your du dx will be 3 1 minus x 3 minus 2 times -1. The -1 comes from is a result of deriving differentiating 1 minus x. Simplify a little bit, although you don't really have to. This is -1, and then the v is 3x squared minus 5x, and surely dv dx is 6x minus 5, and so the dy dx is therefore remember this formula, b du dx, and so just put everything in. You don't have to simplify, so that's good news. 6x minus 5, and then plus what b is. Okay, that's nice. And so this is a -3 1 minus x squared. Okay, so we done that. Okay, I hope you try this again. And second part, very clearly, this is actually quotient, rational function in a way. And so, well, we can take this as u and take this as v, and perform the quotient rule. So we let u be 2e power s, but this is actually 2e power of x power of half, right? And so du dx is going to be 2. You differentiate this, that would be half x to the power negative half. Okay, and then wherever you have it, you recopy at the end. And I'm going to simplify just a little bit. Okay, it's going to be 1 then. And x to the power negative half is actually 1 over square root of x. Please think about that. I'm going to also rewrite this as this form. Okay, and then we're going to let v be x minus 1, and so dv dx is going to be 1, and our task is find dy dx. That would be this use of the formula x minus u dv dx over v squared. And if you put everything in correctly, you'll find that this is x minus 1, but du dx is 1 over root x e to the power of root x. Okay, and minus 2 what u is, okay, 2e so x times dv dx is 1 over v squared. V will be x minus 1 and v squared. Alright, is that fine? And so now I'm going to move on to more of this same question, part C. This is a little bit tricky. As long as you do the first part correctly, I'm trying the part 1. So now first take the part 1. Just be patient. Again, this is a product rule is in use here. So you take this as your u and let this as your v. So I'm not do this directly, but if you're not too sure, you can let u be this and v be this, and do the proper product rule, slowly. And so I'm gonna do u dv dx. So dv dx is 2 over 2x plus then I'm going to do v du dx, so let's copy ln 2x times du dx. So it's going to be 2x, and then this is not you can't multiply, it becomes 4x squared. Please no, don't do that. But then you can simplify this. It's actually 2, but this is 2. You can simplify this. This becomes no 2, sorry, it's x plus 2x in front and ln 2x, right? So this is shown that this case. And now how about the part 2, and hence find this. Now what they're trying to say is you don't have a choice. Please use part 1. And so because differentiating this, you get this answer, and that means if you derive this, or rather integrate this, you would get, with respect to x, you get this answer, x squared ln 2x plus c. Okay, when we're integrating, so there is integration constant. So you see, if you differentiate this, you get this answer. You integrate this, there is answer. This is antiderivative, the property and so on that you probably have studied so far. And so what we're going to do is we're going to work with this. However, they just want this, and let's look through this. Okay, so the question she asked for x ln x dx. Okay, left hand side looks, well, something I can do about it. I can take out the x. That is what property of integration. I can divide by 2. So that's giving us an idea. So the left hand side, we can then express the left hand side as this plus this is equal to x squared ln 2x plus c, right? And so I can perform the usual, manipulation like algebra, right? And so this is what's gonna happen. Plus c and minus this x dx. Giving you an idea. What's this c here? Okay, and the 2 can be kind of factorized, something like that, in that manner. If you think, let's see. Okay, now I'm going to integrate first. Keep everything until the end. And because there's a 2, what I can do is I can multiply across by half, both left side, right side, and so I will end up with, right down here, with the left hand side x ln x dx, which is exactly what we need, right? And so we basically finish our job. But here you have about half x squared ln 2x plus CO2. Okay, keep it as CO2 for the moment. And this is half integral of x. So now the left hand side is done. We leave it and we deal with this ln 2x. Okay, still c over 2, and here would be x squared over 2 plus another something like c1. We don't know, because every time you integrate whatever, you will get c. Now I can't use c again, I've already used it, and so we do not know whether the c, although c is a constant, we don't want to confuse ourselves. And so you get half x squared ln 2x. On the right is front 1 over 4 x squared. Now the problem is the c over 2 and c1. And just imagine c over 2 like number say 10, and c1, well, it's a number like, I don't know, 20. When you add these two numbers up, sum would be just another number. Is it safe to write it as c2, something like that? And so we're done. So this is the answer. When you try to integrate x ln x, isn't it brilliant? Do it this way. Okay, I'm gonna try this. Hope you try these questions, and all the best.